Alright, so 2009, paper 1, question 3, complex numbers. What you're being asked to prove is a property of complex numbers. So it's that basically, if you have z1 plus z2, so bar, that means the conjugate of, you're asked to show that that's the same as the conjugate of z1 plus the conjugate of z2. Just a quick reminder of what a conjugate is. You change the sign of the imaginary part. Okay? So working on the left hand side here, you'll have, we'll leave it under the bar for the moment. You'll have a plus bi plus c plus di. Staying under the bar, a plus c will group together because they're the real parts. C plus di is the imaginary part. The conjugate of it is a plus c minus c plus di. Yep. B, good, good, good. Thank you. Equals, equals, equals all the way down. So z1 bar will z, so that would be a plus bi bar plus c plus di bar. The conjugate of that is a minus bi, c minus di. Group the reals with reals, so that's a plus c plus, it'll be minus b minus di, a plus c, sorry, minus b plus di. So it's a nice handy question, okay? Not that I'd say there was no trouble with that. Okay, moving on anyway, on to the more interesting part. So the A part, the B part 1, you're told A is a matrix, and it's the matrix a half multiplied by 1 minus root 3 1. And you're asked in the A part, the first part of that, to cube it out. So before you cube it, I think maybe you should square it and then multiply it by A. Right? So really what you're looking for is A squared for the minute. So that means a half multiplied by a half. And then the bit that you're really going to be concerned with is that bit. Okay. So it's going to go to 1 over 4 anyway. I don't think that's there won't be too much trouble with that. So, taking my time, how do you set these questions up? Well, the first thing that you should do is that it's a row by a column. The next thing is that it's a 2 by 2, 2 by 2, so the resultant matrix is a 2 by 2. And when I'm doing them, and I want to make sure I get them right, I give myself plenty of space. So it'll be sorry, row by row. So 1 multiplied by 1 plus minus root 3 times root 3. Then it'll be 1 multiplied by minus root 3 added to minus root 3 multiplied by 1. And now you're down. I'll put the second set of multiplication then will be in yellow. It'll go root 3 by that first of all, and then it'll be the second row by that. Well, you have root 3 multiplied by 1 again, plus 1 multiplied by root 3. Then you'll have root 3 by minus root 3, 1 multiplied by 1. You'll tidy all of that up and you'll get minus 2 and that's your A squared. Okay. But what you have to do now is you now have to multiply that by A again. So stick your A in. So you're going to have 1 over 4, then the matrix minus 2 root 3, 2 root 3 minus 2. Multiplying that by A, let's stick the A in the front. doesn't make a difference, but I don't know. So you'll have a quarter. So A is what? A is what? A is a half. You'll multiply that by 1. Over 8. And you'll set about doing the same thing again. It's a 2 by 2. Okay. So quite big. Make a big 1 over 8. Make it easy for you to figure out what goes where. Row and column, and start working it through. So it'll be 1 by minus 2, plus minus root 3 by 2 root 3. Then it'll be 1 multiplied by minus 2 root 3 plus minus root 3 times minus 2. Don't take any chances with the signs. Nice and slow and steady. On to the next row in the second column. So it'll be root 3 by minus 2. It'll be plus 1 multiplied by 2 root 3. And then finally, root 3 multiplied by minus 2 root 3 plus 1 multiplied by minus 2. When you tidy all of that up, that's what you'll get. And just taking the answer just back up here because we'll need it in a second. When you multiply the 1 over 8, remember the 1 over 8 goes into every element. It gets multiplied by every element in the matrix. So your final answer is that. That's A cubed. Okay. Alright, so on to the next bit. What are you asked to do? Let's have a look. Hence or otherwise, find A to the 17. A to the 17. What you need to remember with this, right? First of all, basically you're trying to speed things up for yourselves. You've probably noticed that A cubed is a diagonal matrix. So if I raise that to a power, well then I can just pop the power in for the diagonal. Okay. But it's all about how you're going to rewrite A to the 17. There's different ways to do it, but if you start with A cubed and then decide what else you need to do, well, if I raise that to the power of 5, that gives me A to the 15. Okay? And if I have A to the 15, well, if I put in an A squared, which I also have from earlier on, well, if I have the same, going back to your indices, if I have the same base number, well, that really means that I add the powers, so that would give me A to the 17. So what does all that actually mean? Well, what it means is A cubed all to the power of 5 times A squared is an alternative way of looking at A to the 17. And if you look at the A cubed and the A squared, you actually have all of that information. So A cubed, and again, this is where people get a little bit confused. A cubed, they think the mistake, I'll put it in red so as you know it's a mistake. The mistake sometimes people make is when they're back up here, they see A cubed and they think, oh, I'll put in a 3 here and here. That's not the case. A cubed is equal to that matrix. It's if I raise it to a power of 3, that's when the 3 would go in. So for our purposes, we're going to raise it to the power of 5. So a cubed is the matrix minus 1, 0, 0, minus 1. We're going to raise it to the power of 5, and then we're going to multiply it by a squared. And a squared, one second, is a quarter times minus 2 root 3, 2 root 3 minus 2. This 5 here is going to go in. So minus 1 to the power of 5 is still minus 1. 0, 0, minus 1 to the power of 5, still minus 1. The quarter, well, the quarter can go in at any point. We'll stick it in there at the front. So you've got matrix multiplication again. Okay. Guys, I'm not going to do all that out. Right? The answer that you'll get when you're done is a quarter times 2 root 3 minus 2 root 3 and 2. Okay? And that'll do you. You can multiply that out yourselves. Okay then, almost there. On to the C part. So have a good look at it. Use the Marvers theorem to prove that sine 3 theta is equal to so that's what you're trying to prove. Okay. Now it's a little bit of a cheat. You kind of have to know you kind of have to know what to do, and this bit here gives it away to you. And you also have to make a bit of a jump. You see the 3 theta. Well, that's only making up one part of something that can be written as the cos of 3 theta plus I sine 3 theta. If you reverse the Marvers theorem, in other words, the 3 comes out, that's the same as saying cos theta plus I sine theta all to the power of 3. Now if I cube out all of that, right? If I cube out all of that, I'll be able to work with it. Now you can do it 2 different ways, alright? You can multiply it out by itself 3 times, and if that's what you want to do, that's fine. I'm not going to do it, that's not the way I'm going to do it now. I just want to show you that there's an alternative way. Just to remind, and it reminds you a little bit, the binomial theorem. This is of the form x plus y all to the power of n. And if you remember, the binomial would have said that you'd say n choose 0, x to the n, y to the 0, plus n choose 1. I'm using n, so obviously it'll be n minus 1. Now that's not in its I suppose its correct general form. There'd be n's and r's used normally. The reason I'm showing it to you is this, right? The combination bit here is easy to understand. You remember that the first one is decreasing, and this one here is increasing, and that whatever is here is the power there. Why am I showing you all of that? Well, if cos theta is x and I sine theta is y, I can cube this out really quickly and easily for myself. Okay? And what I'll be left with is something along these lines. 3 choose 0 cos theta to the power of 3 I sine theta to the power of 0 plus 3 choose 1 cos theta to the power of 2 I sine theta to the power of 1 plus 3 choose 2 cos theta. Well, it went from 3 to 2, now it'll be 1. I sine theta, it went from 0 to 1, now it'll be 2 plus 3 choose 3 cos theta to the power of 0 I sine theta cubed. That might seem a little bit awkward, but you try cubing that out for yourself and see how well it goes for you. Okay, so on your calculator, 3 choose 0 obviously is 1. Cos cubed theta. And then I sine theta to the power of 0. Anything to the power of 0 is 1. Now on to this term. Plus, always double check, 3 choose 1. 3. Multiplied by cos squared. And it'll be just I sine theta because it's all to the power of 1. On to the third part. 3 choose 2 is 3. It'll be cos theta. And this is where you have to be a little bit careful, okay? See this bit here? Because the whole thing is being squared. So it's I squared sine squared. And then the last term, 3 choose 3. And cos to the power of 0 is 1. And again, you have to be careful here as well. This is I cubed sine cubed theta. You okay? Alright. I'm just going to transfer that over onto the next page. You're almost there now. All the hard work is done. Alright, so what will we be left with? Tidying it up a little bit. Basically, cos cubed. You know what? Just save me a bit of time before I do that. I originally started with this. And through my binomial theorem and working it down and tidying it up, I now have cos cubed theta plus 3 cos squared theta sine theta plus I have all of that. I can tidy it up a little bit more. So nothing happens for the first two terms. I squared though is minus 1, so it's going to be minus 3 cos theta sine squared theta. And then I cubed. Well, I squared is minus 1 multiplied by I, so that's going to be minus I sine cubed theta, and that's it multiplied out. We're almost there now. What was the purpose of all of that? Well, this is real and this is imaginary, and of course they have dropped down. This is real, imaginary, real, imaginary. Our question asked us to show that sine 3 theta was equal to something else. Now we have a sine 3 theta here, and it's an imaginary part, and it's in an equation or an expression or a formula or an identity, or something along those lines. So we can say, we can equate coefficients, or in other words, reals with reals, imaginaries with imaginaries. And I'm only going to concentrate on the imaginary parts, and I'm going to say that the sine of 3 theta is equal to, you'll notice I'm going to drop out the i's because I did on the left hand side, so 3 cos squared theta sine theta minus sine cubed theta. If you go back and have a look at your what you're actually asked to do, you'll notice that you're asked to express sine 3 theta and everything on the right hand side was sines of some sort. So I'm going to take this bit here, and I'm going to say, well, that's 3, 1 minus sine squared, and that's what you were asked to do, I think. Yeah. Okay. I know it's a lot of work. Now lads, if you didn't quite get the binomial, don't worry, you can just multiply it out yourselves, but the binomial is probably an easier option. Okay, I'm going to keep going on to the next part, and I can put this back up for you again if you need it. On to the C part 2. You were asked, hence find the integral of sine cubed theta d theta. Now, we don't want to work with that. So what we're going to do is, we've just shown something, and they even give it to you in the question. You've just worked out that sine 3 theta you've just proven that that's true. If you isolate the sine cubed, you can sub it back in and integrate that, make it a little bit easier for yourselves. Of course, that's minus 1 over 4. So in other words, the integral of sine cubed theta d theta can be rewritten as the integral of minus 1 over 4 multiplied by sine 3 theta minus 3 sine theta d theta. This is a constant, so it's going to pop to the outside. Just finishing off now, so one more page. So you've got a quarter minus 1 over 4. Just bringing it forward, lads. Integrating each part. And you're done. The only thing you have to make sure you put in is what? Have to put in the plus c. You can tidy that up, so just so your final answer there, just to be a little bit, it's a little bit sloppy. It'll be minus 1 over 4 sorry, I left out a minus there, didn't I? Sorry lads, I'm just going to integrate it again just to make sure I have it right, okay? So sine 3 theta, what does sine 3 theta go to? So we check the sine. be a minus there. Minus stays where it is, so it'll be 3. And that's it.